channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST, that has been your class 8. In that we had started with in the last 7 classes we had started with unit 1, that has been the computer arithmetic errors and roots of equation. In that we had done your bisection method. In the last classes we had completed that. In today's class, we'll have to start with the second method. For the second method, to talk about it, the formula we have for the same is xn plus 1 equals to xn minus 1 upon f of xn minus f xn minus 1 f xn. Initial interval x0, x1 that must be given, or it can be selected such that fx0, fx1 is less than 0. So we'll have to do it. The formula for the same. We'll implement the second method here. As you, if you are not write it down the formulas as I told you in the last classes as well. So you can write it down here. And first of all, it's a huge request to all the viewers to please go through with the subscribe button and please like, share and subscribe our channel, so that many maximum people can get the information at once, and even you can also enjoy the video as well. So we'll go ahead for the question here. Question is, a real root of the equation f(x) equals to x cubed minus 5x plus 1 equals to 0 that lies in interval 0, 1. You have to perform 4 iterations of the second method. Go ahead. Root of the equals to x cubed minus 5x plus 1 equals to 0 that lies in interval 0, 1. Perform 4 iterations of the second method. We'll go ahead for a solution here. So here x equals to 0 and x1 equals to 1. The iterative formula of the second method is, as I told you, plus 1 equals to x and minus upon xn minus fx and minus 1 fxn. Iteration 1, we talk about it. So find out, because x1 we know, we find out for x2. With n equals to 1. Okay. We'll put the value n equals to 1. So what we'll get? 1 minus 0 upon f of 1 minus f of 0 f of 1. So here f of 0 equals to 0 cube minus 5 into 0 plus 1 equals to minus 3. F of 1 equals to 1 cube minus 5 into 1 plus 1 equals to minus 3. Hence above equation become x per 2 equals to 1 minus 1 upon minus 3 minus 1 into minus 3 equals to 0.25. Now we find out for iteration 2 as well. So here we go ahead. We had find out for iteration 1. It is 3 equals to x2 minus x2. It will be equals to 0.25 minus 0.25 minus 1 upon it is equals to 186,441. Now we'll go ahead for iteration 3. So here we go ahead for the same. That is equals to 0.074277 minus 4375 equals to 0.201736. Now we go ahead for the next iteration, that will be iteration 4. For the same we have here input the value here. Zero point 0.074377 minus 0.000471 equals to 0.201640. So note that above root is correct up to 3 decimal places, since 3 decimal places are repeating in x4 and x3. We'll go ahead for the next. We talk about it, that has been another question of using second method that we'll use here. We'll go ahead for the next question, that has been the 35th question of the session here. Here we go ahead. So 35th question of the session we have here. Use a second method to determine the root of the following equation. Fx equals to cos x minus x e to power x equals to 0. Find the roots correct up to 3 places of decimal point. That is the question. We have to find it out for the iterations here. So we'll go ahead for the same. Use a second method to determine the roots of the following equation fx equals to cos x minus xex equals to 0. Find the roots correct up to 3 places of decimal point. So where we go ahead for the solution here. Let's take initial approximations as x0 is equals to 1 and x1 equals to 1 as well. For the same, we find it out for the iterations here. Go ahead here. Let's take initial approximation as x to the power 0 equals to 1 and x1 equals to 1. f0 equals to cos 0 which is equals to 0 e power 0 which is equals to 1, or f1 equals to cos 1 minus e which is equals to minus 2.1779795. Now root lies between 0, 1, 0, 1. So in the following iterations, we will use following recursive equation which we have as follows. So with the same case, we go ahead here. So xn plus 1 equals to xn minus xn minus 1 whole upon f of xn minus f xn minus 1 f of xn here. Now we talk about for the iterations as well. So we go ahead for the same. Iteration 1. Iteration 1. For the same we have, as I told you about, we had find it out for the x0 and x1. So we'll find it out here is for x2 here. So for the same we go ahead. We put the value. Which is equals to 0.314665. Now for the iteration 2 we talk about it. For the same we have here we put the value. Zero point 44678. Now for we talk about for iteration 3. So for the same, we will write it down here so that we will have to find it out for the same. X4 x3 minus x2 fx3 minus fx2 and fx3 will have minus 314665 minus 1 upon equals to. Now we go ahead for the another one which we talk about it. It is the another one here. For iteration 2, we had to put the another value. Sorry, this will be wrong. Upon minus 0.519871, 0.03545 equals to 0.531706. Now we'll talk about for iteration 4. Fx4, we put the value. For the same, we will put the value here for iteration 4, which is 0.531706 minus 0.446 into A upon minus 0.04931 minus 45. It will give answer 0.516904. Now we find for iteration 5. For that we have upon 6904 minus 6904 that is equals to 5.7747. We go ahead for the next one, which is in iteration 6. We talk about it. We'll put the value for the same here. So we put the value here. Minus whole upon 0.00003 minus 0.002593 0.00003, which is equals to 0.517756. Now we go ahead for the next. So here we have sixth approximation to the root, which is your 0.517757, and this is being the for seventh approximation root, and for the sixth approximation root we will have your 0.5.7747 here. So thus approximation value of the root repeats up to 4 significant digits after the decimal point, and hence the root obtained above are correct up to 4 decimal place. So the answer we get is your, which is 0.517757, correct to the 4 decimal place as well. Now we'll go ahead with another question that we talk about it, which is being the 36th question of the sessions as well. So we'll go ahead for the same. 36th question we have, using second method find the root of equation which is x cubed minus 3x squared plus x plus 1 equals to 0. Equation which is for x cubed minus 3x squared plus x plus 1 equals to 0. This is a question here. So we go ahead for the same, and that's what we have to talk about it in the same case for the second method as well. So here we end up with then what we have to discuss, which has been the last question of this, but this will be long here, so we'll continue here in itself. So here f0 equals to 1 and f2 equals to minus 1. Okay, so since f0 and f2 is less than 0, so roots lie between 0, 2. Following table will find out for the rest of the calculation. So iteration 1, number we talk about it, xn, f of xn, xn plus 1, f xn plus 1, xn plus 2. So for this we have to find out this is for 1, 2. Find out with the same that we have as follows. So here we go ahead. That has been x0 equals to 1, 0, x1 equals to 2, 1 minus 1, x1 equals to 2, it is minus 1, and x2 equals to 1. x2 equals to 1, it will be 0, and x3 equals to 1. That we have as an answer. This is the solution for x cubed minus 3x2 plus x plus 1 equals to 0. So here are the roots that is repeating here, which is for f1 is equals to 0 and hence x equals to 1 is the required root here. So we'll go ahead for the next class that we discussed here in the next coming class as well. Here we're gonna end up with, and before ending it up, it's a huge request to all the viewers to please go through with the subscribe button and please like, share and subscribe our channel so that many maximum people can get the information at once, and everything you can also enjoy the video as well. Other than CBNST I'm talking about, we had done your sociology and software engineering. We had done your chemistry as well, in that we had done Unit 1, Unit 2, Unit 3, Unit 4, Unit 5, Unit 6, Unit 7, Unit 8, Unit 9. Logarithm, anti-log conversions with the elements, symbols and atomic mass, atomic number and molar masses of course. We had done understanding the human being comprehensively, the human aspiration and its fulfillment, where we had done Unit 1, Unit 2, Unit 3, Unit 4, Unit 5 with the 2 marks possible question as well. Even though we had done your diagram we are dealing with, and we had done your that is the English vocabulary, which has been important for you all to enhance your English communication, and of course your that has been your skills as well. You can say that the soft skills when you get your vocabulary of course. In terms of quantitative aptitude, yes, in quantitative aptitude we had done your in arithmetical ability we had done operations with numbers and sequencing of numbers, fractions, simplifications, values and cube roots, problems on numbers, percentages, synthesis, and then percentage we are dealing here. After completing that, we'll start discussing about the next topic as well. In terms of reasoning, we had done your verbal reasoning, in that we had done general mental ability and logic reasoning. In non-verbal reasoning, we had done series and logic classification, analytical reasoning, mirror image, water image, embedded figure, completion of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, figure formation analysis, and practice question set as well. Now coming to the CBNST, which has been the computer-based numerical and statistical technique. In that we had started with Unit 1, which is we had started with, and in that we had started with computer arithmetic errors. In that we had done your floating point arithmetic, machine obstacle, round of errors, chopping errors, truncation error, associative and distributive law, and floating point arithmetic, inherent error, error propagation, numerical instability. In roots of equation we had done second method, Newton-Raphson method, and a fixed point iteration method for simple roots and derivations of the rate of the conversions. Attic and acceleration of conversion, modified Newton-Raphson method for multiple roots, Burge-Baite method for polynomial, Weierstrass method for the quadratic factor, and computer algorithm of these methods as well. After talking about that, yes, we will start discussing about Unit 2, which is being the interpolation. In interpolation, we will do algorithm and the error analysis of Lagrange and Newton's divided linear interpolation, cubic spline interpolation. Then we will do your natural spline and Chebyshev's polynomial approximation and cause economization of the power series. In curve fitting, we will do linear and non-linear least square approximation. Third, conditioning in the least square method, Gram-Schmidt's process of the orthogonalization, computer algorithm of the least square curve fitting as well. In Unit 3rd, we'll do differentiation. In that, we'll do the method based on the interpolations and the finite differences. Richardson extrapolation, integration, error analysis of trapezoidal and Simpson method. Newton Gauss integration method, Gaussian integration method, Gauss-Lagrange method, Lohato integration method, and Radau integration method. Error terms in the integration method as well. In Unit 4, we'll do solutions of simultaneous linear algebraic equation. In that, we'll do the Gauss elimination method. Third, condition systems, conditioning number, successive over the relaxation method, rate of convergence, solution of ordinary differential equations, single step method, Runge-Kutta second order, third and fourth order method, multi-step method, predictor corrector method. Statistical technique, we have to do the statistical hypothesis, test of hypothesis, type 1 and type 2 error, level of significance test involving the internal distribution as well. So here we're gonna end up with, and it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and maybe you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and a suggestion on the comment box. Thank you.